Question 5. So I've popped here in red the three trig identities that we're going to be using for this question. So we've been asked first of all to express it in terms of sin theta and cos theta. So given this one, we can reset the question as being 4 over this minus 1 over this. We can then reset the denominator here, just focusing on the sin 2 theta. Well, because sin 2 theta is this, rather than this being squared, we can just have this being squared instead. So we've now got the question totally in terms of sin thetas and cos thetas, hence we're done for part A. Now for part B, we've been asked to show that this equals sec squared theta. So given that we've now got it in terms of this, as an alternative, we can just take this and try and show that this equals sec squared theta. So, this being sec squared theta. So let's kick off by multiplying out the denominator here. So 2 sin theta cos theta times 2 sin theta cos theta is this. The 4's then cancel out. So if we then aim to get a common denominator of sin squared theta cos squared theta, we can do so by just taking the second term and multiply top and bottom by cos squared theta. So we now have a common denominator. So on the numerator we can have 1 minus cos squared theta. That of course is sin squared theta. So we've got sin squared theta over sin squared theta cos squared theta. We can factorize and take out the sin squared theta, giving us 1 over cos squared theta, which finally gets us to sec squared theta, which is what we needed to do. Right, now for part C, hence or otherwise solve this equaling 4. Well, it's always best to do it otherwise. So rather than solve this equaling 4, let's solve sec squared theta equaling 4. Square root both sides, we get sec theta being plus or minus a half. Inverse both, so 1 over sec theta being cos theta equals this inverse, so plus or minus a half. So solve both these solutions, firstly being plus a half, so theta equals inverse cos a half, and secondly theta equals inverse cos minus a half. That gives us a 3rd pi and 2/3 pi.